Yeah, we can give it a few minutes.
I think those sessions came out like a minute or two late. So
You're fine. I'm good. We can give it a few minutes. If not, then we'll have a nice intimate conversation. And it will become very free form and hopefully lots of questions. I don't know, man. Well,
please welcome Benjamin Sterling, Global Director of ICS Cybersecurity at ABS Group. He will be presenting chemical processes, risks in a cyber-physical environment.
So, thank you. All right, so a little bit of background on this topic and what we're going to do. A colleague of mine was originally going to present this and go through it. He didn't hear me, so I'm going to go for it. But a little bit about my background. I got chided based on my last presentation that I didn't mention ABS Group or myself really very much. So I've been in the OT cybersecurity industry for the last 15 years. Before that, I was in IT. But my background is actually in physics, and industry just has always spoken to me. This is what I do. So I come from the electrical sector and oil and gas. Before coming to ABS, I was at Dragos. Before that, I was actually at utilities industry. So I have a little bit of background. So let's start with critical infrastructure and this timeline, which I love and hate this slide a little bit. You know, we're all aware of Stuxnet, Aurora, which this shouldn't be other attacks. That should be just a label there saying demonstration. We've got an increasing timeline of attacks here. But the three things I want to talk about over the last 3 years, which should highlight for everyone, especially in petrochemical industry and so on. Colonial, incidental contact. And I want you to keep that idea in your mind, incidental contact. Because that's one of the risks that get underplayed at conferences like this day in, day out. What happened to Colonial was incidental. It was not targeted at their ICS systems. This was not a targeted attack. It was incidental. That still caused major havoc for not only them, but the nation. And that impact is something to keep in mind, because anytime you're doing risk analysis, the impact is an important part of the equation. And when you can have something like that impact your safety systems in such a way that out of the abundance of caution, you shut stuff down and cause potentially billions and billions, hundreds of billions of dollars of impact to the U.S. economy, that's slightly problematic. The next one here is Pipedream. And the reason why I put Pipedream on there is it's the 7th malware that was targeted at the ICS environments that hasn't been found. I was actually at Dragos when we made the Pipedream announcement. It's a pretty interesting one because it's a toolkit. If any of you haven't looked at this, or you looked at the headlines of Pipedream and said, it only affects the Codesys library, it only affects these handful of PLCs, you missed the point, because you're DCS manufacturers, and if we want to have a conversation offline and we can talk about some more specifics of which ones, use the Codesys library all through their software stack. That is the most commonly used control system library out there. So the implications of Pipedream are not to the small list of PLCs, are not just to Codesys, but a large portion of the control system manufacturers out there. And then lastly, this year, here in February, we had Royal ransomware, which is again, not ICS targeted, get to the control system network of a US energy company. That's kind of a pretty big deal and goes back to that incidental contact thing we're going to be talking about today. So in the chemical industry, you've got hazard analysis, LOPAs, everything else. Risk is nothing new. The problem is how you assess the risk today and what you include in your risk analysis. That's going to be the big key and the big differentiator I want you to kind of take away from this, is that when you're doing your HAZOPs, when you're doing globals, when you're doing process safety management for any chemical release or anything like that, you're thinking about the control system components and cybersecurity in that. Oftentimes, when I'm working with a lot of people in the oil and gas sector especially, OT and IT merge really quickly, especially with the big boys. The big boys, which we've got several of them running around here, do a really, really good job of protecting their perimeter and talking a big game, but when you get inside their facilities, when you look at what's actually going on, the plant engineers and the control system engineers are running the show, which can be okay depending on who it is and what it is. The problem is you don't have a consistent method applied across the industry. So equating OT and IT is a problem. And I see a lot of people in oil and gas doing this. Having spent the last few years before coming over to the dark side as it was in the electric industry, it's absolutely shocking to me where other industrial sectors are. Because the U.S. electric industry, sadly, is pretty ahead of the game when compared to others. So viewing the teams in isolation, and what I mean by this is looking at your IT cybersecurity teams, your OT cybersecurity teams, your control system engineers, your safety personnel as discrete units. They are all going to have to work because in an incident response scenario, they're all going to have to work together. If you don't think that your safety personnel are going to get called in when you have incident response, you haven't thought this through very well yet. So having that mentality of looking at things from a safety mindset, and we're going to get into some of the techniques and things on how, having your IT systems, your IT system engineers looking at the perimeter, probably the people who run your SOC involved with your incident response, your OT engineers, and hopefully your discrete OT ICS cybersecurity practice all working together is just a must for any of these practices. Almost every oil and gas, petrochem, or specialty pharmaceutical manufacturer, anyone in this space just kind of assumes they're not a target, right? We're down on the list. We've got XYZ, we've got a small plant here, we've got a small plant there. Colonial wasn't a target. And that incidental contact still caused a lot of havoc in their particular situation, and can for a lot of people. A lot of companies are kind of just skipping straight to the data diode sort of methodology of, I'm going to put up a big fence around my plant and I'm good. The problem is during a turnaround or any major overhaul, you're going to have contractors coming in. They're going to bring in a laptop, they're going to bring in thumb drives, you're going to have changes to the system. That data diode actually can be an encumbrance in some situations because now I can't respond. Now I have to have personnel at each site capable of doing the job of what a centralized team could do. So it's something to think about. It's not the right answer for everyone, and I think companies make a knee-jerk response that they probably don't need to. And this was a slide someone else put in, but the point here remains, solutions and focusing on tools is not necessarily the right thing to start with. Start with the process, start with the people, make sure that you understand what's going on in your facilities, that you have the safety culture and mindset applied to your OT cybersecurity program, and you'll be far better off than starting off with an IT-heavy approach of insert tool vendor or anything else here. So when we're talking about the teams and viewing them together or in isolation, one of the things that I like to highlight on this one is the domain expertise, because it is something that is required for OT cybersecurity. ICS cybersecurity is differentiated from IT because you don't have the proceduralization that you have in IT. In IT, saying personally identifiable information and going through and categorizing risk is very simple. Categorizing risk in the OT realm is vastly different, because not only do you have to look at the process and understand what is critical to the process, but really when we're talking about misuse and misoperation, what that can mean for the facility requires very specific domain knowledge. It requires your plant and process engineers, requires your operators to be able to assess that risk. That is not a common thing. That is not how this is done in our industry today regularly. When we look at risk assessments and everything else, oftentimes that domain expertise is not involved in the fundamental risk assessment. I'm a big fan of 62443. I've sat on the ISA 99 drafting committee a couple of times and been involved. It's a great process if you follow it correctly. One of the earlier presentations on risk assessment on 62443, one of the things that I would differentiate and suggest to everyone is do a not only component level but system level risk assessment. So looking at the device, what role it has in the production of the facility, looking at its security, how it's going to be applied, what needs to happen, and doing that at each stage. It's a ton of work. We've actually recently done this for a fairly large offshore wind client who is using 62443 instead of SIP-Low. It's a great security practice, but it requires a lot of effort. If you're in new build or a big turnaround, that's when to apply it. Applying it to brownfield operations can be very difficult, so keep that in mind. So a few years back, one of the first presentations I actually gave at this conference, there was a little bit different version of this on the inversion of priorities and what's different. When we're talking OT and ICS cybersecurity and risk, safety is always top of mind. Safety is the top of the category. The CIA triad is obviously different. It's non-hierarchical. It's just the things that we talk about on cybersecurity. When we're talking about the OT world, it's a clear set of priorities. And I actually have changed this a little bit, that safety is the top, availability, integrity, only so that my operators are making the right decision, and then continuity, making sure that we have continuity through an incident response or anything else instead of confidentiality. Because most of the operations, now everybody's got a Coke secret recipe out there somewhere that intellectual property does matter. There are some industries where that matters. But in the vast majority of day in, day out work in industry is fairly common knowledge practice, and confidentiality is less important than these, is what I would argue. So what drives the lack of understanding or underwriting of the risks in OT cybersecurity? It really comes down to, outside of NERC CIP, there are few requirements. After Colonial, we have the TSA directives, we have these things coming in, but the real story of that is industry pushed back immediately against the TSA directives, and they dropped almost all the requirements and backtracked like crazy. So we don't, in the petrochem world, have a whole bunch of requirements tied to cybersecurity. We're starting to see some, but not a lot. Also, we're starting to see insurance underwriting actually driving a lot of the change versus regulators, which is an interesting take. We have a huge lack of monitoring and visibility inside the plant firewall. As soon as you get inside the plant firewall, DCS, or even pipeline SCADA systems and so on, visibility from a cybersecurity standpoint largely goes away. That's not the same in all industries. It's not the same in every case, but it's a large truism. The root cause thing is actually one of the most troubling things to me. If you have a unit trip off, if you have something where you've got to get production back up and going, a lot of times logs are not even reviewed. A lot of times evidence is not collected. It's more important to get production back in play than it is to look at root cause. Oftentimes, 9 times out of 10, it's going to be some, instrument error, compressor failed, and you had something go wrong that caused a process trip that was not cybersecurity related. But the fact of the matter is, it makes me wonder, since we're not doing any of this root cause analysis, how much we're missing as far as exploratory stops into our networks, because we don't have the visibility. The threat environment is obviously constantly changing. What we see geopolitically and going on, whether it's in the Middle East, which has a large impact on oil and gas and petrochem, or in Ukraine with Russia and certain pipelines going boom. you're seeing an emerging threat environment that, yeah, Nord Stream and what happened there was obviously someone planting explosives and everything else. But realistically, control of the pipelines that are currently going across Ukraine and in Ukrainian control, what happens if they overpressure? Are we really confident that Soviet-era pipeline construction is going to be good? I don't know. We'll find out. Most companies are not prepared for this. When we look at what Sands and Dragos and others have to say about surveying their customers and looking at what is actually deployed in the field, we have over 50% of the companies out there, and this is across ICS industries. This is electric, this is oil and gas, this is manufacturing, this is everybody. But we have over 50% have little to no network segmentation. And I think that is probably pretty true of everybody in this room, that your networks are pretty flat. That's very common discovery. The uncontrolled access to the OT environments. Just to tell you a little bit of a story, I was working for a large utility here in the US, and I was actually at one of our power plants and doing a walk down, meeting with plant managers and everything else. And I noticed this little Connex trailer that someone had brought in and set down next to the water demineralization building because their water demin building was offline. So they brought in an outside trailer. There's an antenna sticking up out of there, and I opened up the trailer and went in, and sure enough, there was an Allen Bradley panel view, HMI, running Windows XP, unpatched, firewall disabled, with a cell modem connected to it that was tied into the DCS network. It's one of those things that it's not exactly a fun day, and it brings up questions about vendor management, but, how do you detect that? Even if you have a good visibility program, which most don't, even if you are monitoring your networks, that dual-owned HMI that's sitting out on the open internet, the processes and the procedures and the management and focus on your OT environments and OT cybersecurity is kind of a key piece there. Because if you have the right management and you can put in place the policies that say purchasing orders and talking to vendors, you will, you shall, you must, you cannot do these things. It's not perfect, but at least it's something. And unfortunately, sometimes procedural controls are where we need to be. And in that vein, how many of y'all have seen the Swiss cheese model? Okay, so this is used in safety all the time. Your safety guys are going to know this. Your plant operation guys are going to know this. You know why? Because it gets preached to them all the time about engineering controls, the things, the handrails around your facility that's an engineering control to keep them from falling off. Administrative controls that say, hey, don't go do that. Behavioral controls and PPE, glasses, hard hats, those sorts of things that are kind of that last line of defense. And then making sure that post an incident, a full review is done to see where the failures were and how the holes aligned in your defenses to be able to get through it. When I talk about a safety mindset and applying that to cybersecurity and using that as part of our risk analysis techniques and how we're communicating to the plants, this is a tool. This is a tool that drives culture. This is a tool that's already embedded in the culture that you should be using. And if you're not, I personally think you're missing an opportunity. It's a way of describing things. It's a way of going back and looking at root causes of incidents and talking to the plant in the terms that they are already used to. Another one I really like, and I actually use this technically all the time, and I'm going to show a couple ways to do it, is the bow tie hazard analysis. In the petrochem industry, this is old hat, right? This happens all the time. We're going to talk about how to use this in cybersecurity. We're going to go through a couple sets of information that we collected that I think you'll find interesting. But for those that are not familiar, on the left side of Bang, before you have the event, you have threats, you have your controls and barriers to those threats that are preventing you from getting to that event. And eventually, you're going to have enough holes that you're going to get to the event and eventual hazard. That hazard could be physical. It could be a chemical release in terms of a LOPA or something like that if you're doing this sort of analysis, or it could be a data breach. You have your barriers to restoration, and finally your consequences. You can put these together and do levels of analysis into a kill chain. if you haven't thought about this, this is really useful. So what we can do is we can look at a compromised corporate asset, what barriers we have to prevent that, where we can get to it, and then how we can pivot through the environment. You can put these analyses together and stack them together to create a kill chain that gives you a really effective representation of your controls and where you can stop that Swiss cheese model from occurring, right? So finding those holes, finding the pivot points all the way through the environment. And of course, if I were doing this for a customer or we were doing it in a little more detail, you would, instead of having pivot to the historian, maybe I have a vendor over here that's got turbine controls on a power unit or something like that. You could have multiple pivots from here. And apparently I'm going long. So this is a slide that's a little bit overdone. I want to save time for questions, and since I'm at 10 minutes, we're going to skip ahead here. We have a landside facility, we have a terminal, and corporate and internet in between. We have facility controls, onloading, offloading, etc. This is an eye chart, and be glad that they put out the slides because this is useful. But here is an actual detailed analysis of some of what we have found from various work that we've done with certain agencies. That this is our work product, but this is a good representation of what you can do with that bow tie hazard analysis. So we have policies and procedures, we've got architectural, we've got configuration, we've got all these things that are considered for an exploit, right? And we look at how this breakdown can occur. This is kind of the top view of all the controls in a particular environment and how we would represent this to your company. Right, or to, you could represent this to a facility and start looking at this. So if we take a specific attack scenario where an attacker comes in, changes some of the automation, and starts to overfill a tank, disable some of the safety sensors, things like that, how would we represent that in the same bow tie analysis? And now it kind of looks like this, where we have the various scenarios, where the failure points are, what the actual hazard we're thinking about is, the barriers and the consequences. So you see how we can go from a process safety scenario to a cybersecurity scenario and model those consequences out in a very effective way. And when you start putting these together in that kill chain, all the way down the process level, it becomes a very valuable tool, not only to talk to your plant personnel, not only to talk to operations, but for your cybersecurity personnel to think about where the holes in your defense in depth structure are that you can improve your posture. So with all that, and where I'm going to end so that we have some time for questions, are your cybersecurity, safety, and operation teams ready for this? Are they ready to take that next step and really start looking at your LOPAs, your PHAs, everything else with cybersecurity in mind? And I'm going to ask you this question, because a lot of you are going to say, oh, we've got analog safety systems, we've got everything else. How many level indicators do you have that are radar, that now have Bluetooth on them, that are a system on a chip design, that are not considered a cyber asset in your LOPAs? Until you can answer that question, I really think you ought to consider it. Anyway, with that, I'd like to thank you for your time and say if you have any questions, I'm happy to address them. All right. Well, thank you.